Today we're starting our unit on transformations, and the first two that we're going to talk about are translations and reflections. So we'll start with some terminology. Here we go. An operation that maps an original figure called the preimage onto a new figure called the image is a transformation. All that means is I've got this figure, or it could even be a point, and I'm going to take it and I'm going to move it in some way, or maybe transform it in some other way. And we call the pre-image, let's say we're talking about point A, we would call A the pre-image, and once we map it or move it somewhere else, we're going to call it A prime. So this would be the pre-image, this would be the image. That's the way we use that terminology. Okay, a transformation can change the size, position, or shape. I'm going to put a little asterisk here, and I'll tell you why, because I took this quote right out of your book, but I don't think we're going to talk about any transformations that change the shape of a figure. So I'm a little bit iffy on that shape. If you can think of one or find a transformation that changes the shape, then let me know, but I'm kind of doubtful about that. We're going to talk about transformations that change the size and position. So if we have a transformation in which the pre-image and the image are congruent, that's called an isometry. So clearly, an isometry is not going to change the size of the figure, right? So an isometry, I can change the position, but I'm not going to change the size, or it's no longer an isometry. Okay, translations and rotations are both isometries. Excuse me. And what is a translation? It's basically a glide, like I'm sliding something up, down, left, or right. It's a transformation that maps all points of a figure the same distance in the same direction. So if I look at the pre-image A here, I'm sorry, and I got the image A prime, it's been shifted right and up, right? Wait, B moved, oh, well, this is a different example. Sorry, if I'm just looking at this one right here, I can see that A goes to the right and it goes up. So that means every vertex on that triangle is going to go the same distance right and the same distance up. Okay, so look at this little example. It says B, and I've only got to, if I want all the vertices, I've only got to do it to one to figure out what the rule is, and I know all the others are going to move in that same way. So here, B, pre-image B moves 4 units right and 2 units down, so every vertex of that square would move the same way, and so we could write a translation rule that says X goes plus 4 because it's 4 units right. Since Y goes down, we're going to put Y minus 2, and I know that every vertex of that square is going to use that same mapping rule. Okay, look at this one. Write a rule that describes the translation of the quadrilateral PQRS to its image. So what I'm going to do is I'm just going to pick one of the vertices. I'm going to pick R because it's down here closest to my hand where I'm writing. And let's see, what do? I go 1, 2, 3, 4, 5, 6, 7, 8. 8 units to the right. So my rule is going to be X goes to X plus 8, and Y goes 1, 2 units down. So Y minus 2. All right, simple as that. Okay, now we may have more than one transformation going on, and when we do, we'll call that a composition. A composition of transformations. It's a combination of 2 or more transformations. In a composition, you perform each transformation on the image of the preceding transformation. And what I like to do is I go from pre-image A to image A prime, and then if I have another transformation after that, I like to call it double prime. And then if I had a third, I'd call it triple prime. In general, the composition of any two translations is just another translation, right? If I shift a figure twice, then I could have written just one translation for the total move. So a composition of translations is just another translation. So that's it for translations. Let's talk about reflections. And then at the end of this lesson, there are quite a lot of practice problems for you to do, so you get plenty of practice. A reflection across a line R, called the line of reflection, is a transformation with these two properties. If a point A is on line R, so in other words, if one of the points of your figure is on the line of reflection, then it's just going to map onto itself. A equals A prime. So that's just what's going on here, right? You see this point A, this pre-image point A, it's on the line of reflection. So when you reflect it, it's going to stay on the line of reflection. That's all that's telling you. And point 2 is, if a point B is not on line R, then R is the perpendicular bisector of the segment that connects the pre-image to the image. So look at your picture here. Here's my pre-image point B. Here's my line of reflection. I'll dash it in red just like they did. Okay, you see since A was on line R, A prime is also on line R, and B is up here, and I know when I do the reflection across line R, B prime is here, and this line R is the perpendicular bisector. Perpendicular bisector of the segment that joins B and B prime. So that's a good way for you to figure out where B prime is going to be, right? You find the slope of R. You'll probably know what that is. You'll have the equation of R probably. And then you know that the slope of B prime, that segment, is going to be the opposite reciprocal, right? Okay, so all we got left now for the rest of this lesson are a whole bunch of practice problems. I'm going to probably do one for you, and the rest of them, I'm just going to put the answers up here, and if you have any trouble with these, then we can talk about it in class. Let me see. I want to pick one. Let me just put the answers up here for this one, and you do need to graph these. So we got a triangle ABC. This one is very easy. We're going to reflect it in the x-axis, which is right here, right? You always want to highlight your line of reflection. There's the x-axis, and of course we remember that its equation is y equals 0. And when I reflect all these vertices in that line, I'm going to get A prime is going to be -4, -2. You do this and you'll see 4, -7, 5, -1. I am going to check to see that you did these, so even though I'm going quickly through it, you go ahead and graph these and make sure I got my answers right. Okay, let's look at the next one. This is a rectangle, so even more points. We're reflecting in the y-axis. So here's our line of reflection. So you're going to want to graph the pre-image. The image vertices are going to be -1, 2, -2, 5, -8, 3, -7, 0. You can pause here and do these, or you can write down all the answers and then come back when I stop this video and do it. Okay, I'm going to do this one with you right here. What I am going to do is I'm going to pause to put my vertices up here, RSTU, and then so you can pause and put RSTU on your coordinate plane, and then we'll come back and do this together. All right, so I've graphed my square RSTU with all the vertices, and what are we going to do? We're going to reflect in the line x equals -1. Always sketch in your line of reflection. So what do I know? Well, I know that x equals -1 is the perpendicular bisector of the segment that's going to join all the pre-image points to their image points, but really what I know is that all these points have to be the same distance away from the line of reflection once it's on the other side of the line, right? So I'm just going to count. Since I got a coordinate plane, I'm just going to count. So R is 1 to the right of the line, so it's going to be 1 to the left. When I reflect it over S, I got to go 1, 2, 3, 4, 5, 6. So I'm going to go 1, 2, 3, 4, 5, 6 to get S prime. U is 2 units to the right of the line, so I'm going to come over 2 units to the left of the line, and T is over here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So that should give me T prime. Sorry, that's prime. And there is my reflected square over the line x equals -1. What are the vertices? Well, the vertices of R are -2, 3. Vertices of S prime, I'm just going to count these now. I already did it, so I'm just going to fill them in. -7, 4. T prime is -8, -1. And U prime is -3, -2. Let me just count that one to be sure. 1, 2, 3, 1, 2. Yep, I believe that's got it. So sometimes the line of reflection isn't going to be the X or Y axis. It won't always even be a vertical or horizontal line. So you got to think about that. Let's see if one of our next problems, oh, here's one. Here's one where our line of reflection is not a vertical line or a horizontal line. It's Y equals -X. What does Y equals -X look like? Well, it's the line that goes through the origin with a slope of -1. So we're going to sketch that in there. So there's Y equals -X. And I'll go ahead and do this one. Let me pause and graph my triangle, STU. I'll be right back. Okay, there's STU graphed in there. And so I'm reflecting over this line. So watch this, guys. What I'm going to do now is I'm going to start with point T, right? And what I see that I have to do is I have to go up 1, 2, 3. I got to go up 3 units to get to the line of reflection. So if I just go then over 3 units, that's going to give me my point of reflection, my my reflected point, my image. That's going to be T prime right there. And I can see that if I were to draw this segment that connects those two, that line of reflection will be the perpendicular bisector. So really, if I'm on a coordinate plane, all I got to do is count. If I'm going up to get to the line of reflection, then I'm going to go over and so forth. So let's see, what is that point for T prime? It's 1, 2, 3. 3, 0. Oh, and it's right here, 3, 0. Okay, let's do U. U, I just got to go up 1, so I'm going to go over 1 to get U prime. And so that's going to be 4, 1, 2, 3, 4, -3. 4, -3 for U prime. And then finally for S, how far up do I have to go? I got to go 1, 2, 3, 4, 5, 6, 7. So I'm going to go over 7 from that point. 1, 2, 3, 4, 5, 6, 7. There's going to be S prime. Here's going to be my triangle. And if you sketch in every one of the segments connecting the pre-image to the image, you will see that the line of reflection is the perpendicular bisector for each one. What are the coordinates for S prime? 6, 1, I believe. 1, 2, 3, 4, 5, 6, 1. Yes, 6, 1. Okay, so look at what's happened here. Okay, my line of reflection is Y equals -X. So just for example, let's take S, which was -1, -6. What if Y equals -X, then X is going to equal -Y, right? So if I just apply that to these coordinates here, then if Y equals -X, -1 is +1, and if X equals -Y, -6 is going to be +6, so that does give me the vertex that I found of that triangle. So when the line of reflection is Y equals -X or Y equals +X, you can just apply that rule to your vertices, and you don't even really need a graph to find out what the reflected vertices are. Okay, so I'm going to leave you to do the rest of these. This one here is just a translation, triangle STU. It doesn't require a reflection. Translations are super easy. So let's see, I got -4. So here we go. S prime is going to be -5, -3. T prime is going to be 4, -6. U prime is going to be -3, -7. My notes, guys, are actually a little bit different. They're in a different order than what I am putting on the board here for you. So please double check me and let me know if I got anything out of order or messed up. Let's see what we got here. Just another translation, trapezoid ABCD. So A prime is going to be 1, 5. B prime is going to be 4, 6. C prime is going to be 5, 3. And D prime is going to be -1, 1. And I believe this is the last one. Oh, no, it's not the last one. Okay. Write a rule describing the translation below. Remember, all I got to do is pick one vertex and count. And so what I have here is that X, Y. I'm just giving you the answers. You're supposed to do the work, remember. X plus 7, Y plus 4. That's what I got for my rule. Let's see what's on the next page. Ooh, you got two reflections. You got two transformations. So what I want to tell you here on these is that when I do my reflection, I'm going to call these points Q prime, R prime, S prime, T prime. And then when I do my second transformation, the translation, I like to call those double prime. Remember I told you that? So I'm going to rename these double prime. And I'm going to tell you what the answers are. But since this is the first one of this kind, you definitely need to go ahead and do it. -4, -5. Don't just write down my answers. I'm going to look at your paper and see if you did it. You know that. -5. Maybe not tomorrow, but one day. -7. -6. That's what I got for my answers. You better do it to make sure I'm right. And then this is the last one. It's another composition. So remember, you want to call these double prime. You want to call your first transformation prime. Call these double prime. And what I got was 6, -7, 6, -4, 1, -4. Now guys, these are pretty easy, honestly. So if you don't need to do all of them, that's okay. But I do expect you to at least do a couple or three of the ones that I didn't do to make sure that you are an expert. See you next time.